You've seen how the mean and median are two ways of finding the measure of central tendency for a dataset. In this video, you'll learn a special case of finding the mean, also called the weighted mean. Let's start with an example. In a machine shop, there is a collection of three sizes of cylinders. What is the mean height of these cylinders? How does it compare to the median height? You might be tempted to find the mean of 6, 4, and 2 as shown here. But that would be a mistake. Finding the average of 6, 4, and 2 this way assumes there's only one of each. But as you can see, there are 4 of the 6-inch cylinders, 4 of the 4-inch cylinders, and 3 of the 2-inch cylinders. To find the mean of this arrangement involves using the weighted mean. Here is the formula. This looks like a more complicated formula, but it's not too different from the mean formula you're familiar with. The W factors are the weights given to a particular item. This is where we take into account the different number of items. Let's try it with our scenario. There are 4 6-inch cylinders. The highlighted 4 is the weight given to the 6. There are 4 4-inch cylinders. Again, the highlighted 4 is the weight given to the 4. There are 3 2-inch cylinders. Again, the highlighted 3 is the weight given to the 2. The denominator is the sum of the weights. So you see the 4 from here, the 4 from here, and the 3 from here. Simplifying, we get this expression, which further simplifies to this term. The weighted mean is approximately 4.18. Now let's find the median. Arrange the 11 data items from least to greatest, as shown here. The median is the middle term, or the 6th data item, 4. Comparing the weighted mean and the median shows very similar results. Let's look at another example. At a gym, there was a collection of kettlebells of different weights. What is the mean weight of the kettlebells? Compare it to the median weight. This is another example of having to find a weighted mean. Why? Because there are different numbers of the 3 main categories of weights. We need to calculate the weighted mean. Here is the formula. Let's start with the numerator. There are 5 32-pound kettlebells. This is expressed as 5 times 32. There are 8 24-pound kettlebells. This is expressed as 8 times 24. There are 4 16-pound kettlebells. This is expressed as 4 times 16. The denominator shows the sum of the weights, 5, 8, and 4. Simplifying the numerator, we get this expression, which then leads to this expression. The result is about 24.47. Now let's calculate the median. Arrange the weights from least to greatest, remembering to account for all the weights. There are 17 terms, so the median is the middle term, which is 24. Comparing the median and mean, we see that, like the previous example, they are close in value. Do you think this is always the case? Also, how do you think the median accounts for the weighting factors? Let's look at a final example. At a daycare center, there are 5 1-year-olds, 15 2-year-olds, and 12 3-year-olds. There are also 5 25-year-olds and 3 35-year-olds. What is the mean age? Compare it to the median. This is another example that requires a weighted mean. Here is the formula. There are 5 1-year-olds, shown here, 15 2-year-olds, shown here, 12 3-year-olds, shown here, 5 25-year-olds, shown here, and 3 35-year-olds, shown here. The denominator shows the sum of the weights. Simplify the expression to get this expression. Simplify further to get this expression. The mean is 7.525. Now let's calculate the median. For large data sets, you should use a spreadsheet. You can arrange the data items as shown here. Here are the 5 1-year-olds, 15 2-year-olds, 12 3-year-olds, 5 25-year-olds, and 3 35-year-olds. If you're using Excel, use the median formula and include the range of cells. The median is 2.5. Contrast this to the weighted mean, which is 7.525. This is an example where the median and weighted mean are not close in value. Which measure of central tendency would you use to describe the average age at this daycare center?